Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as logic. Let's see this. Today we are going to do truth table. Start writing, guys. Construct a truth table for P and Q or not P. Right? P and Q or not P. Let's see this truth table. The first two columns will always be the two variables given to you, P and Q. So the first column will be P, the second column will be Q. Right? Now start from the bracket. You need P and Q. You need P and Q. You need a not P. And you need or between P and Q or not P. Okay. Now you always write this as TTFF. You always write this as TTFF. This is going to be TF. Fine. Now how do you do AND function, guys? I'll explain to you that AND function, for AND function, if both the conditions are true, only then the answer is true. Otherwise the answer is false. Here P is true, Q is true, so the answer will be true. Here one of the condition is false, so the answer is false. One of the condition is false, therefore the answer is false. Both the conditions are false, therefore the answer is false. So for AND function, if both the conditions are true, only then the answer is true, otherwise the answer is false. Right? Next, NOT function. Let's see this. NOT function, for NOT function, T becomes equal to false and false becomes equal to true. For NOT function, this is your NOT function. Whenever you are doing NOT, true changes to false and false changes to true. True changes to false and false changes to true. Okay, that's your rule for NOT function. This V is a OR function. What is the rule for OR function? If both the conditions are false, only then the answer is false. If both the conditions are false, only then the answer is false. If both the conditions are false, only then the answer is false. Right? This one of the condition is true, so the answer is true. Both the conditions are false, therefore the answer is false. One of the condition is true, therefore the answer is true. One of the condition is true, therefore the answer is true. That is going to be your answer. That's going to be a 3-mark question. Fine, do we get this idea? Let's see this. Let's see one more table like this. Suppose if you had P and not Q implies P or Q. Right? Let's see this truth table. How do you make truth table? The first thing that you have to do is write P and Q, write the two variables. Now see your bracket. You want a not Q, so first you make not Q. You need P and not Q. P and not Q. You need P or Q. And then you need an implication between these two. I'll call this as 1. I'll call this as 2. So I need an implication from 1 and 2. Right? How do you make the truth table? It is always TTFF. This is TF. NOT function. How do you do NOT function, guys? NOT function, true becomes false, false becomes true. I want a NOT of Q. True will become false, false will become true, true will become false, false will become true. That's your NOT function. Right? Then I need AND function between P and not Q. What is AND function? If both the conditions are true, then the answer is true. Here you have true and false, so the answer is false. Both the conditions are true, answer is true. Both the conditions are false, answer is false. One of the conditions is false, the answer is false. For AND function, the ulta V, AND function, if both the conditions are true, only then the answer is true. For OR function, if both the conditions are false, only then the answer is false. This is your OR function. I want OR between P and Q. T or T is T, T or F is T, F or T is T. Both the conditions are false, therefore the answer is going to be false. If both the conditions, yeah, you want to ask me something?
So in P and not Q, so you said both, if they're true, then it's true, no?
In AND function,
Yeah.
the both are true, so the answer is true. I'm taking AND between P and not Q. I'm taking AND between the first column and the third column.
Oh.
Right? And OR is between the first two columns. Now, I want implication. What is implication function, guys? TFF. Yes, very good. If the first condition is true and the second condition is false, then only then will the answer be false. Right? This is FT, so this will be T. This is TT, will be T. FT, T. FF, T. Unless and until you have TF, only then the condition will be false, or only then the answer will be false. Fine, did we get this thing here? How to make this truth table? Right, let's see another sum, guys. Not P or not Q, biconditional, not P or Q. Right? Truth table. P, Q. Right? You need not P. You need not Q. You need not P or not Q. Not P or not Q. Then you need P and Q. You need not of P and Q. And you need a biconditional between this and this. 1 and 2 biconditional. Right? How do you solve the sum? You write TT, FF, TF, TF. This remains the same. Okay. Now, not. How do you do not function, guys? For not function, T becomes false, false becomes T. So I want not of P function, not of P variable. So T becomes false, T becomes false, false becomes T, false becomes T. I want not of Q. So F, T, F, T. True becomes false, false becomes true. Or, I need or between these two. OR function, if both the conditions are false, only then the answer is false. For OR function, if both the conditions are false, only then the answer is false. Here both the conditions are false, therefore the answer is going to be false. Here both the conditions are not false, here both the conditions are not false, here both the conditions are not false, therefore the answer will be true. Next, AND function. I want AND between P and Q. Okay. For AND function, if both the conditions are true, then the answer is true. Here both the conditions are true, so the answer will be true. Both the conditions are not true. Both the conditions are not true. Both the conditions are not true. Right? I need a not of this. For not, true becomes false, false becomes true. True becomes false, false becomes true. Right? Next, bicondition. Biconditional, if both the conditions are same, then the answer is true. Otherwise, the answer is false. I want bicondition between this and this. Both the conditions are same. This is also F, this is also F. Therefore, the answer is true. Both the conditions are same. This is also true, this is also true. So, the answer is true. Both the conditions are same. Both the conditions are same. So, the answer is true. If both the conditions were not same, that is, if I had true and false or false and true, in that case, then the answer would have been false. That's the rule for bicondition. Let's see one more sum, guys.
So, the values of P and Q in the beginning are preset?
Yes, preset. That is, you always start with the TT, FF, TF, TF. That's how you do.
So for the not P and Q.
Not P or Q it is.
No, the second last. This
one.
one. How did you do that?
I have P and Q. I have to do not of this. So I have to do not of this particular column. So T becomes false, false becomes T, false becomes T, false becomes T.
That's for everything. And then if there is
Just a single function or a whole bracket, right? Let's see one more sum. Suppose if I had P implication not Q and R, right? Now so far the sums that we had seen had only two variables. Here this sum has got three variables. It has got P, Q and R. Truth table. There are going to be three variables, P, Q and R, right? I want Q and R. Q and R. You need not function of that, not of Q and R. Then you need P implication not of Q and R. Okay. Now, like he asked me, are these preset conditions? Yes, but they are preset conditions for two variables. Here you got three variables, right? Since you got three variables, the last two variables you will use the same rule. T, T, F, F. T, F, T, F. Right? When you have three variables, repeat the process again. T, T, F, F. T, F, T, F. So when you have three variables, you repeat the process with your Q and R. Now for P, you will put 4 T's and 4 F's. That's how you get your various conditions for three variables. Now once your T and F is fixed, then you can go on solving. You need a AND between Q and R. AND function. If both the values are true, only then the answer is true for AND. If both the conditions are true, only then the answer is true. Both the conditions are true, not true, not true, not true. Both the conditions are true, not true, and not true. Right? You need a not of this. So this particular column, I need to do a not of this. Not. For not, true becomes false, false becomes true. So this is false, true, 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 false, true, true, true. Right? You need an implication between P and not of Q and R. Now guys, implication is TFF. The first condition is true, the second condition is false, only then the answer will be false. T, F, T, F, so this is going to be F. T and T, T implication T, T implication T, T implication T, F implication F, F implication T, F implication T, F implication T. So your answer will be this. This will be your truth table. Fine, do we get this in here? Done? Everyone's done till here? Let's move on again ahead. This was when they ask you to construct a truth table. Next, they will next type of question that they can ask you is determine if the following statement pattern is tautology, contradiction, or contingency. Right? Now, let's see this. They will give you a sum like this. P or not of P and not Q. Whatever is the sum given to you, you first make a truth table of it. So, truth table. Right? How do I make a truth table? You will write P, Q. You always first write P and Q. Let's see the bracket. I need not Q. Then I need P and not Q. P and not Q. Then I need not of P and not Q, right? Then you need P or not of P and not Q. Fine, do you get this thing clear? Now, this is going to be TTFF, TF. Okay. Now you need a not function. How will you get a not function? T becomes F, F becomes T. T becomes F, F becomes T. Right? I need and between P and not Q. I need and between P and not Q. T and F. Now for and function, if both the conditions are true, then the answer is true. Here both the conditions are not true. Both the conditions are true, therefore the answer is true. Both the conditions are not true. Both the conditions are not true. Right? You need not of this. Not. For not function, F becomes equal to T and T becomes equal to F. So F will be T, F, T, T. You need a OR function. Now the condition for OR function, if both are false, then the answer is false. You need a OR between P and this. Both the conditions are not false. 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 Now guys, if you look at the last column of your truth table, it has got all T's. Such a condition where the last column of your truth table has got all T's is called as tautology. So you will say that since the last column of the truth table has all T's, therefore the given statement pattern is a tautology. Right? So that's how you find out a tautology. Fine, do you get this? Can I rub the first sum out, guys? Everyone's finished copying the first few sums? I'm rubbing the first three sums out. Next. Suppose if they tell you not of P or Q and P, you have to find out what is the statement pattern, right? Let's make a truth table for this. Truth table P, Q. First of all, let's find out P or Q, the bracket. Then you need to find out not of P or Q. Then you need a AND function with this. So not of P or Q and P. Right? Now, this is going to be T, T, F, F, T, F, T, F. Right? Standard pattern. You always start with T, T, F, F, T, F, T, F. OR function. OR function, if both the conditions are false, then the answer is false. Here both the conditions are not false, both the conditions are not false, both the conditions are not false, both the conditions are false, therefore the answer will be false. I need a not of this. Not. True becomes false, false becomes true. So false, false, false and true. I need AND between this and P. Now AND function, if both the conditions are true, only then the answer is true. Here both the conditions are not true, both the conditions are not true, both the conditions are not true, both the conditions are not true. Right? Now if you look at the last column of your truth table, guys, if you look at the last column of your truth table, it contains all F's. Such a condition where the last column of your truth table contains all F's is called as contradiction. You will say since the last column of the truth table contains all f's, therefore the given statement pattern is contradiction. Right? Let's see another sum, guys. P implication Q and Q implication P. Let's make a truth table for this. Truth table. P Q, P implication Q, Q implication P, and you need a and between them. P implication Q and Q implication P. Right? T T F F, T F T F. Right? Now for application, what is the rule? TFF. If the first condition is true and the second condition is false, only then is the answer false. If the first condition is true and the second condition is false, only then the answer is false. This is not TF, so this will be T. First condition is true, second condition is false, therefore the answer is false. Remaining all of them will be true. Right? Next. Now when I am seeing Q implication P, I will have to see the reverse way. So TT is going to be T, FT is going to be T, TF. This becomes my first condition, this becomes my second condition. First condition is true, second condition is false, therefore answer is false. FF is T. You need a and. What is the rule for and? If both the conditions are true, only then the answer is true. Both the conditions are true, both the conditions are not true, both the conditions are not true, both the conditions are true. Right? Now in this case, if you look at the last column of your truth table, it does not contain all T's or all F's. If you look at the last column of your truth table, it does not contain all T's or all F's. When the last column does not contain all T's or all F's, then it is called as contingency. Since the last column does not contain all T's or all F's, therefore the given statement pattern is contingency. That's how you find out whether it is tautology, contradiction or contingency. Fine? Let's see another sum, guys. Next type of sum. Suppose if they tell you, show that the following pair of statements are equivalent. Show that the following pair of statements are equivalent. Right? Let's take a sum. Suppose if I had a sum like this, P and Q, comma Q and P. Right? Now, let's make a truth table for this. Truth table, P, Q. You want P and Q. You want Q and P. Fine? T, T, F, F, T, F, T, F. Right? Now, AND condition. For AND function, if both the conditions are true, only then the answer is true. Here both the conditions are true, answer is true. false, false and false. QP, I'll be reading in reverse order, right? But the rule still remains the same. If both the conditions are true, only then the answer is true. So TT is going to be T. Both the conditions are not true, both the conditions are not true. Now if you look at column number 1 and column 2, you will see that they have the same truth value, TFFF and TFFF, right? I can say that since column 1 and 2 have the same truth value, therefore P and Q is logically equivalent. This is the symbol for that, 3 lines. P and Q is logically equivalent to Q and P. That is how you find out logical equivalence, right? Let's see another sum of this kind, guys. Suppose if you had a sum like P implication Q and not P or Q, I have to prove their logical equivalence. Truth table. P, Q, P implication Q, not P or Q, right? This is going to be TTFF, TTFF, TFTF, right? Implication. What is the rule for implication? If the first condition is true and the second condition is false, then the answer is false. If the first condition is true and the second condition is false, only then the answer is false. Here both are true, so the answer is true. First condition is true, second condition is false, therefore the answer is false. This is going to be true and this is also going to be true, right? Here the first condition is false, here also the first condition is false, therefore this is going to be my output. Now not P. For not, true becomes false, false becomes true. True becomes false, both the trues will become false, false becomes true. I want not P or Q. For all, the rule is if both the conditions are false, only then the answer is false. I want this and this. Both the conditions are false, only then the answer is false. Both the conditions are false, only then the answer is false. Now if you look at column 1 and column 2, they have the same truth value, TFTT and TFTT. So you will say since column 1 and 2 have same truth value, therefore P implication Q is logically equivalent to P implication Q is logically equivalent to not P or Q. Fine, do we get this thing here? Next, let's see another sum of this kind, guys. Look up the first few sums. P biconditional Q and they give you not of P and not Q and not of Q and not P. I have to prove that these are logically equivalent. Let's make a truth table. P, Q, P biconditional Q, right? Now I need not Q, then I need P and not Q, then you need not of P and not Q, right? So this out also. Then you need not P from the bracket. Then you need Q and not P. Then you need not of Q and not P. You need a and between this and this. You need 1 and 2. Okay, let's make the truth table for this. T, T, F, F, T, F, T, F. Biconditional. What is the rule for biconditional? The rule for biconditional is if both the conditions are true, then the answer is true. The rule for biconditional is if both the conditions are true, then the answer is true. Here, both the conditions are true, so the answer is true. Both the conditions are same, only then the answer is true. Here, both the conditions are same, therefore the answer is going to be true. Both the conditions are not same. Both the conditions are not same. Both the conditions are same, therefore the answer is true. If both the conditions are same, then the answer is true in the case of biconditional. Not. I want not of Q, right? Not of Q. T becomes F, F becomes T, T becomes F, F becomes T. Then I need P and not Q. P and not Q. I need AND function between P and not Q. And if both the conditions are true, only then the answer is true. Both the conditions are true, then the answer is true. Here both the conditions are not true. Both the conditions are true, then the answer is true. This is going to be F and this is going to be F. If both the conditions are true, only then the answer is true. That was only in this case. Okay. Now I need a NOT function. NOT function, F becomes T, T becomes F. F becomes T, T becomes F. Then I need not T. Not again, F becomes T, T becomes F. So this is F, F, T, T. Fine. Next, Q and not P, right? Q and not P. I need Q and not P, and function. If both the conditions are true, only then the answer is true. If both the conditions are true, only then the answer is true. So Q and not P. This is false, false. Both the conditions are true, so the answer is true. And this is false, right? I need a not of this. Not. True becomes false, false becomes true. So this is true, true, false, true. Fine. Next, you need a AND between first and the second function, right? And if both the conditions are true, only then the answer is true. Fine. Both the conditions are true, answer is true. False, false. Both the conditions are true, the answer is true. Now if you look at column number 3 and column number 4, they have the same truth value, TFFT and TFFT. So you will say since column 3 and 4 have same truth value, therefore P biconditional Q is logically equivalent to not of P and not Q and not of Q and not P. Fine. This finishes the sum. We will stop this here for the day. Thank you very much.